Thank you for coming. My name is Yehuda Sadeh. I've been with the Ceph project for a bit, and now I'm working for Ubiquiti. So the topic I want to talk about is a project that I've been working on the past year during my previous work at IBM, which is RGW Bucket Snapshots. And it's a project that's still in development. Currently it's been taken over by Shilpa from the RGW team. And the motivation for RGW Bucket Snapshots, there are many different reasons, but the main motivation at the time when we looked at it was how can we take RGW and do backup. And there were a few solutions, but the one main solution that was proposed is using activity logs for that. And activity logs, let's say, are not the perfect tool for doing backups. They're created asynchronously. You cannot really control the timing. They might not show all the data. It's very racy. So you cannot really do a point-in-time consistency or application consistency. So that was the main reason why I took a look at that. And there are other use cases like cyber resiliency or the ability to set data working set and then revert to it, which is not quite implemented. So RGW and S3 API has object versioning, and you say, why not go and use that feature instead of introducing snapshots? Now, object versioning is great for archival purposes. In object versioning, every object you put, every new object instance, you create a new version. And basically, you have the full history of all the objects, and it's immutable. So you can definitely go over all the objects and then back them up, but it's a per object history. You can't really get an application state, consistent application state, because you might have more than one object. That's one thing. There's data bloat, because if you have an object that keeps being overwritten, then you might have 1,000, 2,000 objects there, 10,000. So what is bucket snapshots and what's the capability? So basically, we have the ability of a user to turn on this feature on a bucket, the ability to create a snapshot, which, snapshot is similar to how it works in file system, how it works with block storage. Delete a snapshot, list a snapshot, that's all like user operated, not an admin operation. You can list listing a bucket when a snapshot was taken. So you took a snapshot, you put in some more objects, and then you list the bucket. You get the bucket, the view of the bucket as if it was when the snapshot was taken. You can do list of the changes of the specific snapshot. So what did the snapshot introduce? It is new objects, or maybe objects that were deleted. And also list the changes between two snapshots. So if you have, every day you take a daily snapshot, and then every week you take one weekly, you can, hey, give me all the changes between those two weeklies. And obviously, most important, you can actually get the data for each object per snapshot. So it's not just showing you what the snapshots have, but also the objects that might have changed in between snapshots. You can get the old data. And part of the implementation, we introduced S3 API. So it's fully integrated into S3 API. So how is that being done? So the short version is basically we take object versioning and extend it. So adding a new dimension to object versioning. So object versioning, for those of you who don't know, you turn on object versioning on a bucket, and at that point, every object that you put gets a version ID, which is kind of random string. When you access the object, you don't need to specify, give me this version, but these versions exist, and you can go back to you can list all the versions, and you can go back to all the versions. So now we introduce snap ID. Every bucket instance has a snap ID associated with it, which is the current snapshot that it's actually preparing. Once you take a snapshot, this snap ID is increasing. So it's monotonically increasing. Every object that is created in the system is getting that snap ID. So you are at snapshot 1, every object that you put will get snap 1. You created a snapshot, now every object you put will get snap 2, and so forth. So once the snapshot ID or snapshots has been enabled on the bucket, we treat internally the buckets as if they're versioned. So we look at all the mechanisms, all the versioning mechanisms that exist, and leverage them basically to show different instances of objects, even though they're not necessarily versioned objects. Internally they're versioned, but exposed as non-versioned. One thing to note is for versioned objects, once you turn on versioning on a bucket, you cannot go back. So you can suspend versioning on the bucket, which means that objects will get a null version, but you cannot really disable that feature. So there exists the case where objects have null version. So as I said, objects can still have null versions, but what happens if you put an object, take a snapshot, and put the same object? Both of those instances have the null version. So basically the same object. So that new dimension that we introduced, the snap ID, makes it so that we store different object instances in the system. And I can give you this example where on the left side we have a chain of operations that we do. We put object A, object D, object C, take a snapshot, delete object B, and so forth. And on the right side from bottom to the top, you can see all the objects that we now have in the system, where in the circles, that's the dimension of which snapshot they belong to. So you put object A, object B, object C at the beginning before snapshot. Before you took the first snapshot, they're getting to be part of snapshot 1. You deleted object B. We now need to mark it as deleted. It's not a delete marker like in versioning, it's a bit different. But there's still an object B that exists on the snapshot 1. So how does that work with the objects themselves? We can look at how non-versioned, and I really want to focus on the non-versioned cases, it's a more interesting case. How non-versioned objects are being handled by Rados. So in order to access non-versioned object, you have the object name, you have some information about the bucket, you create some string out of it, and that's the Rados object name. So you can directly access that object. There's a head object, that contains a manifest and might contain some data, and the manifest tells you where all the rest of the data is. But basically, that's all what you need is that object name. In versioned objects, you have an indirection, which we call an OLH, object logical head. The indirection points, that OLH points at the latest version of the object. The object might be named foo.xyz, then the OLH will say, okay, that's where you need to go now. So basically, like a link, like a soft link. RGW, the bucket snapshots feature, modifies the OLH in a way that it gives it new capabilities so that we can track all the snapshots where the object exists. So it's not just pointing at the latest one, it basically points at every latest instance in any snapshot that it was created, not any snapshot. For example, if an object was created at snapshot 2, then it was overwritten at snapshot 5. It'll have an entry there for snapshot 2 and for snapshot 5. If you access snapshot 4, will resolve into the snapshot 2 instance, right? It still needs to be accessed. So you go to the OLH and look at that map and see, oh, the object is in snapshot 2. The bucket index in versioning is really doing the heavy lifting, and it's no different in this feature. Bucket index, as you know, tracks of all the object instances. Now, the new feature in bucket snapshots, other than adding that new dimension of snapshot, it needs to track when an object is deleted. Because if you created an object and it belongs to snapshot 2, and now you are in snapshot 5 and you want to delete it, and then you overwrite it again, it's snapshot 6, you might have this gap, then you need to track, because if you want to read it at the snapshot 5, you're supposed to get does not exist. So the bucket index is keeping track of all of that. The bucket index also tracking the stats per snapshot. So we want to look at how the bucket looked like when you were at any snapshot, that including the number of objects and total size of these objects, and it's gonna return that. And also, obviously, the bucket index is responsible to do the listing filtering when you say you want to have a listing of a specific snapshot, it's going to do that. Some complications that are different in the case of snapshot versus regular operation is, for example, when we're dealing with object overwrite. Beforehand, you put an object X, you overwrote it, we automatically know that the object was overwritten because it existed before. But now we have a new dimension. The previous one might have been at snapshot 3, and the next one is in snapshot 4. It's not the same instance as far as the index is concerned. So that's something that had to be taken care of. And also there's a case where an OLH now can point at nothing. That includes both the index and the OLH itself, the link itself, because it could be that object only resides in snapshots, but it is currently in a state where it was deleted. And finally, the process of removing a snapshot and cleanup is being handled by that when a user wants to delete a snapshot, we we move that snapshot into a list of the, snapshots that are about to be removed. And then we actually trigger the lifecycle process with internally going over all the buckets and all the objects in each bucket. And then for each object there, it checks, does this object belong in a live snapshot? Because it's not enough that the snapshot that the object was created at was deleted. It might belong to some later snapshots that were taken. So if that object still needs to exist, we keep it, otherwise we remove it. The removal is a special operation because, we actually need to remove it and not to mark it as a deleted for the current snapshot. As I said, version buckets are not as interesting, but you can still take snapshots of them. Like everything works the same, just that every object that you create also have a new version ID. One thing that's a bit different is how we reference the object instances internally, which might not be as interesting, but non-versioned, we now have the name, the instance, which is null, and a snapshot ID. In the version case, we don't keep the snapshot ID. We keep what we did before. We just keep the name and the instance. And the reason is we cannot create a versioned object with willy-nilly whatever a snapshot ID is. This object is only be created in that specific snapshot. So to avoid the extra lookup through the OLH in order to access it, we just keep it by how we kept it before, so that if you access a specific object with a specific version ID, you go to it directly. Other considerations and limitations. Objects cannot be removed if they are in a snapshot. Like you want to delete the object, it's not going to be removed because it's in a snapshot. And that's by design. You want to remove the object, remove the snapshot and everything else. So that's a feature, not the bug. Accuracy can still be changed, though, for each object, and that's in line with what versioning is doing. And it's some kind of a security issue. If you put an object that is publicly visible, and you don't want it to be publicly visible, you can still change the accuracy for it. Accuracy by themselves are kind of a dying breed. And one more thing, it's a zone local feature. The feature does not, as it is now, it does not go through multi-site. So you create a snapshot, it's not creating it on other zones. We looked at what can be done in multi-site. We never got to an agreement of what would actually make sense. So at this point, what we're doing is basically keeping it to the local zone, and everything across the multi-site is going to look as if snapshots do not exist. Also, we limit the configurable that limits the number of snapshots that can be created on a bucket, and the default should be like a few hundreds at this point. And the reason is that because of OLH and index scaling, right now we keep it pretty much in a trivial encoding on the objects, and you don't really want to surpass that. And not just that, there are other places where we do that lookup, where we cannot really go to an external entity to check or to shout that. So that's how we deal with it right now. That's a future improvement. There are currently Boto extensions that support for the API the changes that that I introduced. And the API extensions are, there are operations that to enable bucket snapshot create, list all the bucket snapshots. There are two parameters that are interesting that are added, HTTP params. One is snap ID and the other one is snap range. Snap ID references a specific snapshot. Snap range references a snapshot that starts after a specific snapshot and to a second snapshot. And all the object operations that are retrieval using snap ID. As I said in the beginning, it's still in development. The feature itself is pretty much feature complete. Shilpa started working on it. I'm going to continue contributing to it. It still needs more testing. There's some tests that were created. And you can look at the PR here. Now, I don't know how much time we have. We do have, and if it's going to work. I have a demo. So here I create a bucket, my bucket. And put a file in it. You can see it. Can you all see it? Looking at the data, V1, F1, V1. Let's list the bucket. We have object F1, size 11. Now I turn on bucket snapshots on the bucket. Create the first snapshot. And you can see that snapshot ID is 1. Name is snap1. From now on, I'm going to use the snapshot ID. The API, I think, supports the name. I'm not sure. So you can list the bucket snapshots. We have snapshot 1 is created. Currently, the bucket snapshot ID is 2. So every object that's going to be created now, going to have 2. And I'm listing the object versions. I can see that we have object F1 that belongs to snapshot 1. Now, this is not necessarily going to be the final feature as it is. We may not want to expose that this way, but for now. So I put the object, overwrote it with F2, and now it holds version 2. But if I'm getting version ID 1, number 1, snapshot 1, then I'm getting V1. Putting a second object that also has V2 in it. And we list the object versions. Both of them contain the same data at this point. But if we're going to look at the bucket again from the point of view of snapshot 1, we see the original version. We create a new bucket snapshot. Now the ID for this snapshot is 2. We can look at the snapshot range between 1 and 2. So what happened between 1 and 2 is that object 2 was created, object F1 was created, and object F1 was overwritten. The object F1, the original version from snapshot 1 was overwritten. And we have all that information here. So a backup software can take that and know which object it can go and back up now. We deleted now F1, and now we're trying to get it, we get 404. But if we get the version that was in snapshot 2, we get it, and the same goes to version snapshot 1. Yeah, and that's how the bucket looks right now. Like we can do all sorts of other listing, what happens from 0 to 1, 0 to 2, but that's about it. Yep. And to move forward, that's it. Thank you, and if you have any question. Yes?
Some buckets can be rather active,
Right.
rather dynamic. Is there any sort of locking or pausing mechanism when you run the snapshot to kind of hold the bucket in place as it is?
If there's any locking for when taking the snapshot, no. Not at this point. We did discuss a mechanism that would identify erasing snapshot that was taken while an object was created. It's not quite implemented, but it's in the design. But basically, an application can stop its own activity and takes the snapshot, and at that point, everything. Yes.
So now on the sharding part for the inversioned buckets, when we design the bucket and decide how much shard it will be, now one metadata object Rados will not be corresponding to the one actual object because of snapshots. You introduce some.
I'm not sure I heard you.
When we are creating the bucket, we need to decide how many shards we assign to this bucket. By default, it's like 11. But now with inversioned buckets, and if we have snapshots, we will have additional usage of the metadata. So it will not correspond like one object Rados in
Right.
data to one object in data.
That's true. When you introduce, even with versioning, you don't have a single object instance per object, right? When talking about how to calculate the number of shards you need per bucket, for object versioning, you always say multiply everything by 4. So now snapshots, and it's not about the versions themselves, but it's about how we manage internally in the bucket index, how we manage everything. So you have multiple OMAP keys per object, and that's why you need to multiply by 4. Now you need to make your calculations based on how many snapshots are going to be expected to be taken times number of objects time and take into account what's the activity that's going to happen between those. So it's never very easy to know in advance, but it's something that needs to be taken into account. Yeah. Yep.
If your bucket has 100 million objects, how many metadata operation snapshot will do?
How many well, first of all, if you have 100 million, it's going to be sharded quite, right? It's not going to be one shard, it's going to be 10,000 shards or something like that.
3,000, whatever.
Yeah.
That's how long it will take to create a snapshot over.
Snapshot creation is immediate.
Yeah.
That snapshot creation is only happening on the bucket instance. Metadata. So we don't iterate over everything. We don't go over when you create a snapshot, we don't go over all the objects. What happens is only when you create a new object. Right? So all the objects stay the same. We don't update the OLHs and everything. So.
Only if I would update all 100 million, then I would have a heavy metadata change for this snapshot.
Only if you go over all the objects. Yeah, but yeah, it's all one to create a new snapshot. Deletion is different. Yes.
You spoke about it a little bit, but because you have to store a bunch of extra data to do the snapshotting, and also, as you mentioned, for deletion, you have to like do a bunch of extra checks. Are there not concerns about like exacerbating issues with like hot PGs on the bucket index of like having to do more work in like centralized locations? Like have we quantified that?
Are there other?
Well, just because you need to store more data to store all those snapshots, and as you said, for deletion you have to do a bunch of extra checks on that data in the bucket index. Are we concerned about sort of exacerbating issues with like hot PGs in the bucket index of like all the metadata operations we have to do on that sort of small set of data, or is that not an issue?
Well, one of the reasons why we limit the number of snapshots that user can create is to deal with it. So you don't want things to blow up completely. It does gonna put more weight into it, but it's kind of in the same line of object versioning. And if here you don't need to turn on object versioning, so you're not going to create a new instance per each write. So, it's a trade-off. Anything else, anyone? Alrighty, I think we did it. Thank you so much.